I will start with introducing David Greenwood, who will open the session. He will be followed by Lars Carlstrom and Jacqui Murray. Then there will be a discussion with regard to what's been discussed, and hopefully be able to cover any questions that you may have. So thank you very much, and it's over to you, Dave. Thank you.
Thank you very much, Peter. So welcome to this session. The topic for today is really around establishing a UK battery manufacturing supply chain, and especially that one critical link in it that we're all looking for, which is our gigafactories. You'll have seen a lot in the news. Boris Johnson's talked about it. You've seen it in the UK industrial strategy. Batteries are really seen by the UK as being a strategic investment and a strategic opportunity that we must make the best of. Historically, the UK has had a defining role in batteries. Some of the industries that you are watching this video on today are powered by lithium cobaltate batteries, which came out of an invention from Oxford University in the 1980s and resulted in a Nobel Prize just last year. So we clearly have some of the scientific and technical competencies that are needed in this area. But the question for today is, what is it going to take for us to put a significant industrial presence in place, manufacturing hundreds or thousands of tons of batteries and generating significant value for the UK? So if you could go to my next slide, please. So the UK is a thriving car industry. At its height, it's making typically 2 million cars a year. Right now, we're not in that position, but I'm sure we'll be talking about that later. And in particular, within that, we've had a long-term strength in powertrains, that's engines and transmissions and the like. And the engine or transmission makes up about 1/3 of the value of a car today. But as you move from that internal combustion engine car to an electric vehicle, we replace the engine with an electric motor and a power electronics, and that costs about the same as the engine that it replaces. And we replaced the fuel tank, which used to cost about 250 euros, with a battery that can cost anything up to 10,000 euros. So what you're seeing is that this battery, this energy store for our electric vehicle, really becomes a defining component for the car, both financially and in terms of its design and in terms of its functionality. And that 8 or 10,000 euro component, multiplied up by the number of vehicles that we manufacture each year, builds an industrial opportunity for about £5 billion a year worth of turnover in supplying batteries just into the cars that are made in the UK. One view of that is that that's a significant industrial upside that we should be stepping into and gaining. A complementary view is that if we fail to do that, then we don't just lose the opportunity to make that £5 billion worth of batteries, but we may also see automotive manufacturers move their vehicle assembly to the plants where they do assemble their batteries. And if that's the case, we don't just lose out on the 5 billion opportunity, we also lose out on a lot of the existing industry today around vehicle body, accessories that go with it, and the tier 1 and the tier 2 supply chains that link with that. And that's why you'll see the battery has been highlighted in industrial strategy as being that we need to make. Could we go to the next slide, please? If you look at the shape of that supply chain, there are quite a few steps in it. So starting on the left-hand side, we have materials. These are typically electrochemical materials, things like graphites, things like engineered powders of mixed metal oxides. They move into factories that produce them into electrodes, which are long materials that contain these electrochemicals. And those electrode sheets are then folded or rolled or stacked to form cells, which are the individual building blocks of our battery. The cells are assembled into modules, the modules into packs, and the packs into vehicles, where hopefully they last for at least 10 or more years before taking their final step in this circular chain, which is to move into some form of recycling and material recovery. If you think of what we've got in the UK today, that central block around modules and packs and vehicles is likely to be occupied for high volume manufacture by the OEMs. And in the UK, we have OEMs like Jaguar Land Rover, like Nissan, BMW, Toyota. So we have a natural infrastructure around us that could capture that part of the value chain. We also have a chemicals industry, particularly in the northeast, that stepped up correctly could step into that left-hand part, the manufacture of the raw materials that go into our batteries. But right now, apart from, as I'll talk later, there is one plant in Sunderland that we have at AESC, formerly Nissan, which is doing cell assembly at 1 gigawatt hours per year. We don't have a multi-gigawatt hour per year cell assembly plant in the UK. And that really is the prize that we're looking for. The next slide, please. If I was to really go into the detail of where all those materials come from, what you'll see is a remarkably complex supply chain. It takes its components from all over the world. Some of them are incredibly simple, plastic moldings, metal stampings, and some of them are much more technically complex, micron scale powders of mixed metal oxides that are scale. In the UK, some of those chunks already exist, some of them don't. But to develop those that don't, what we need to pull them through is a buyer of those materials. It's as simple as that. And that's why this missing link, this gigafactory part of the value chain I talked about earlier is so critical in this. If you go to the next slide, please. If you look where the value is in a battery pack, what you'll see on that upper left pie chart is that the sort of bluey area is the materials that go into the cell. And so you can see that actually a very significant part of the value of our battery pack is in the materials themselves. But that quadrant at the top left corner is the value that's associated with the cell manufacturing, the module manufacturing, and the pack manufacturing. And when you remember that we're talking about a £5 billion per year business, a quarter of that is absolutely not to be sniffed at. If we were to go deeply into the materials, the next thing that you'll see is that the majority of the value in those materials is around the cathode electrode, in particular around the micron cell particles that make up that electrode. Overall, there's a significant industrial opportunity for us to move to, please. And just to give some sense of scale to that, if we look at the volume and the mass and the value of materials that are coming through, cathode materials alone, we're looking for about 69,000 tons of material per year to support the UK supply of batteries. And these are high value materials. That's £1 billion worth of supply per year. These are really significant numbers. And they're the sorts of numbers that need organisations that can act at scale. With the best will in the world, an SME is not going to step forward into that scale of business in a short space of time. They may develop the technology, but to grow to that scale quickly is going to need some very careful financial engineering. Next slide, please. In the UK, the good news is that we've got much of the infrastructure that we need around us to do that, because that development path typically starts in a university or a laboratory working on materials at the gram scale. From there, it would move into a facility such as ours at WMG, where we take those gram scale materials and we turn them into fully functional cells for the first time and work out how they might be manufactured. The next step up from that is to understand not just how you make one cell, but how you make 3 cells a minute, something like something that is a slightly smaller scale of the full industrial facility which is going to be produced. And that's there to de-risk the manufacturing process and make sure that when we spend several £1 billion on building a battery factory, we've got very high confidence that the products it produces will be fit for purpose and at the quality that's needed. And all of that is intended to prepare the ground to attract organisations to the UK to make those £1 billion investments in gigaplants which have the ability to supply our industry. Next slide, please. In terms of users of the products from those factories, we do have a reasonably vibrant supply chain. So if you look in the auto sector, we have quite a lot of automotive manufacturing and assembly happening within the UK, and that's typically the customer for that type of gigafactory. The question is around whether there is a consolidation of demand or whether there is a clear enough demand signal to get that investment in place today to put the factory in place. But if you look beyond automotive, we're now seeing the aerospace sector and even stationary energy storage starting to rise up in their importance as customers for these types of cells. And on the upstream side of all of that, if you look at the chemical industry, we've had tremendous success in engaging dozens of companies who are already operating in different markets with materials of similar style, similar quality, and similar quality. So with this missing gigafactory piece filled, there is a very good argument that there's strongly in this market. Next slide, please. So if you look at where we stand today, the UK was actually the first country in Europe to have its own battery manufacturing plants. And that was the Nissan, now AESC plants up in Sunderland, set up originally around 2 gigawatt hours per year of manufacturing. It's now running a little more than that. But if you look at the size of plants that are typically being invested today, they now have 10 or 20 gigawatt hours per year in order to be financially competitive. And the question for me is, where is that going to appear? What do we need to do in order to make sure that it happens, and how can we help? And with that, I'll close my presentation and I shall hand over to Lars.
Thank you so much, David. It was very useful to hear all your thoughts about gigafactories in the UK, and we hope to solve that problem pretty soon, as we have a very ambitious program to establish a gigafactory, or actually a gigaplant as we call it, in the UK. And you can do the next slide, please. We are actually choosing the United Kingdom as our preferred site for building a gigafactory. UK is our home base, and where we have a long history in the battery technology, as mentioned previously. We have been amazingly well received and have a great future for the UK for the battery manufacturing, where we actually can fill a gap in the industry currently. Next slide, please. Why choosing a United Kingdom? And well, I've been saying it this way. UK, first of all, have an amazing history when it comes to manufacturing. And we have identified UK in the way that everything has been so extremely well prepared. It's like it's been preparing for the Olympic Games, but without any competitors, and everything is so well furnished. So nothing can be more easy actually than implement our business plan in the British supply chain, and from the support from the British government, we are amazingly impressed about the situation currently. Next slide. United Kingdom, as mentioned, had a very long history of innovation and advanced energy storage, and also mentioned previously with the original lithium cobalt oxide battery at the Oxford University. An invention that changed the way we live our connected lives and has started to change a way of living, really. So it's actually the home of batteries where we are currently are. Next slide. We are building the Giga site. It's actually an 80-hectare site for our Giga plant, and it will also include a supply chain that we hope to attract and to add on to our business, and to make the impact on the environment as low as possible, as long transportations and CO2 emissions will actually damage the process in a way we would like to minimize. So therefore, we would like to have the Giga site as a center of our production, and has as many suppliers close to the factory. Next slide, please. We would like to be the front runner when it comes to the latest innovations of process and equipment, and to ensure our cost of manufacture drive the economics of the battery industry towards partly with legacy solutions, ensuring high levels of efficiency and productivity, the highest yields in the industry, and the lowest environmental impact of any battery production facility. We will keep waste to a minimum and recover, reclaim, and reuse as many of the consumable materials and chemicals used in our process as possible. And we expect to recycle as much as 80% of the battery in the end of the day. Next slide. And here comes our Infinity Center, which we are currently developing, where we will realize this vision and make sure that as much as possible will be recycled in a proper way. And as mentioned before, up to 80% is where we currently are in terms of recycling process. Next slide. There we are. We are actually a first mover in the UK market for building a giga plant, and we are very close to finalize a MOU in Wales, where we are planning to build our first factory, and that will be built in 3 stages, where we are building 10 gigawatt and another 10 and another 10. So in total 30 gigawatt is what we are initiating, and we are planning to put a shovel in the ground early next year. So it's pretty soon, and we have a very ambitious program to make all this happen. And we are very optimistic about being successful with this process. I think we can interact actually and together here and discuss. There are some questions actually that we should identify and to pay some attention to. And maybe David, you can initiate and start this discussion us in between.
But first, I thought I might just hand over to Jacqui just to talk a bit about what the Faraday Institution and the Faraday Battery Challenge is doing to support some of these things in the UK.
Thanks, Dave. Lars, I'm just down the road from your potential site in South Wales, so I'm hoping that I get one of the first invites.
Sure.
So if you want to put my slides up, I think what Dave's covered a lot of this, so I'm going to talk quite fast through it, but important really from a government perspective to understand why batteries, and it's not because we're obsessed with them, it's because actually when you look at what the challenges are for government and even more in the middle of COVID, it's a really important space to understand well from a policy perspective. So if you want to flip the slide over. So Dave was sort of alluding to how difficult this is for automotive, and it's useful to put this the why into an automotive context because it's easier to understand. We talk about in the Department for Business, obviously we talk about the business growth and we talk about jobs, but the reality is right here and right now, it's about saving the planet. And what you've got on the right-hand side is a graph of CO2 emissions for Europe and those regulatory points. The blue line is over time and the red is predicted. What you have on the left, however, is if I wanted to make a car and I have £1 billion to spend in a big car company, it's going to take me 42 months to design it and validate it. And then I'm going to need it in production in one form or another for about 10 years before I start really recouping my money. And it's not until sort of year 7, year 8 where I start to actually make profit. So when I then overlay that timescale onto 2020, you can see I need my fleet average down at sort of 67 grams per kilometre. The issue with that is even with hybrids, I'm going to struggle to hit that. So I need a full big fleet of full electrics so that my legacy cars, my bigger SUVs that are all counted in these figures come out as an average that is that low. So if you flip over slightly, over one page, what you see is for the last two, and 2019 isn't in there, but actually emissions have started to go up on average. And there's reasons for that, right? We all like to drive an SUV. We're reaching the limit of what we can do with internal combustion technology. And also there's been a shift recently from diesel following Dieselgate to petrol. And that's also seen a shift in the way way cars are being tested. So you're seeing much more real world figures. So you can see that creeping up. And that's an issue, right? We know that climate change is a significant issue. And also we know air quality in urban areas in particular is an issue. And you can see both of those things right now through COVID under close scrutiny. So what we're talking about is a massive transition. And I think just at this point, I wanted to just put some numbers in there. What COVID is doing that's really interesting is changing the forecasts. And the presumption is that, you know, the forecast is down, you know, it's everything stopped, everything stalled. We saw in April a sort of 97% reduction in car sales, but actually EVs didn't experience quite that. So from the beginning of the year, what we've seen is a decline of 55 to 66% drop, depending on whether you're petrol or diesel. But actually EVs have only dropped 21%. And I think it's quite surprising that in May, the biggest selling model in the UK was the Tesla Model 3, and that's a full EV. And so it's really interesting. Partly that's going to be because of the way they sell them online and without showrooms, but really interesting to see that at the forefront. So we flip on another slide. I'll give you a bit more on what we're seeing. So these are old graphs. So it's a bit difficult in the middle of COVID to sort of ask you to believe them, but I think what they do is show you trends. And we see trends on vehicle sales that show that by 2040, we're going to continue to see growth in automotive. And those are vehicle sales, and this is why cell manufacturing is important. And it's important because the trend that's coming alongside them is actually that battery OEMs are moving towards where the automotive or the vehicle manufacturers are. And we're seeing that regularly, and you can see that in lots of different parts of the world. So if the UK can grab onto that cell manufacturing, that battery manufacturing, as Lars just sort of talked about, actually what we're then seeing is that we can start to see really useful amount of UK produced batteries. So if you flip on one more, and there's a reason for that. And it's always useful, I think, sometimes in presentations just to help people dig behind. That's a nice statement to make, but why? And the answer is right now, you know, obviously COVID this year has messed up these figures again, but let's say last year, those full electric vehicles, you had 17.3 million quid in transit in terms of the batteries and cells moving over around the world. What you're looking at is if those graphs start hitting their predictions, then you're starting to have in transit, you know, billions every year. So having nearly $1 billion of your supply chain in transit becomes unfeasible. And you can then start to see why actually being closer to it. And I think in the discussion, we'll talk a little bit about what's coming as well. And that's the other reason. Being close to the product producer allows you to work with them much closer on these complex battery systems. So if you flip over one. That slide's gone a bit hinky, but that's okay. So I borrowed this slide from our partners in the Advanced Propulsion Centre. They're not very happy that that's gone a bit strange. But what I wanted to show was actually why Gigafactories keep being talked about. And it's this linchpin, it's this keystone, I guess, is in this diagram. It sort of shows that actually if you have that keystone, you can build either side of this up. And that's what we're looking at. So whether it's from recycling and people having concerns about how much recycling capacity we have in the UK for EV batteries, actually with that keystone, you can start to put some very serious plans in place. If it's on raw materials or if it's on materials processing or chemicals processing, same again. And you start to build this piece when you have that clarity over direction, because you have in the middle that manufacturing piece of Gigafactory. So if you flip over one more. So I'm sticking to automotive and I'm going to expand out of that. So Dave, remind me if I don't. But why are gigafactories so critical right now? And we talked about, and you see again, APC talking around that 42-month and 10-year design, development and production needs for a vehicle. But the reality is this isn't a mature technology. So we know that the way cars feel and their acceleration and their performance and their range is a differentiator. So cells tend to get viewed as, you know, those AA batteries or the things that are in your laptop, but actually for vehicles, they very much aren't a commodity. So when you're looking at that, and you're looking at a new vehicle, actually your propulsion system is really important. So they're not that commodity right now. So as you're bringing on tenders for your new vehicle architectures, actually the big OEMs are looking for the next technology. And I'll talk therefore why UK BIC and Faraday becomes something really interesting. We also know, and I've showed you the graph, that CO2 targets are really important, but also we have constant messaging that these global battery makers are really, really planning, and they're very, very conscious about that next phase of scale up. And all the graphs that I've shown have been around vehicles, but actually they're mainly based on automotive and light goods, and actually you start to get into HGVs, you start to get into mining equipment, you start to get into off-highway, you start to get into marine and rail. And actually the demand for rechargeable batteries starts to get bigger and bigger as you get nearer the need for electrification, the net zero agenda that government has becomes more and more important. And we know we've got issues. You know, we know with Brexit there's some risks, okay? And actually that's one of the reasons why you see the government really focused on this right now, and as we take into account the impact of COVID on the economy. So if we flip over, what I want to talk about is what I've been doing. No, actually I won't. I'll talk about why that's so important. So these are figures, and I can only really flash them up for a short period, but I always think it's really useful. So what you've got there is on the right, you have China and the Eastern European blocs. And what you can see is we've started to really analyze what those costs are. And we can see that it's more expensive, but actually a little bit more expensive in the UK. And it's actually slightly more expensive to do that in Germany. And actually then when you put that into the context that Lars just spoke about, in terms of how green the national grid is, for example, how well you can demonstrate your environmental impact right the way through, actually the UK has some other offers that's really important. You know, we have been running without coal-fired power stations, you know, regularly for the last 18 months, and it's really interesting to see how low carbon our grid has got in a very rapid space and time. I used to regulate power stations, and for me it's just been fascinating since 2002. So now if we move on, I'll tell you what I've been doing with the Faraday Battery Challenge. If you can just click up all there, the next. So we had £274 million since 2017, and we've allocated that to the Faraday Institution. Lars and David both spoke about batteries and the Nobel Prize winners in Oxford. And on that base, since 1980, actually the UK have continued to invest in university research. So the Faraday Institution, the aim of it is actually to bring together those universities that have been doing something or have complementary skills into 9 multi-institutional, multidisciplinary research. And it's really interesting for me because actually what you might even have in universities is departments working on research, but you might be in the engineering department rather than the chemistry department. And actually these focus projects bring together the best we have in the UK. And I think there's around 28 of the UK universities participating in this very proactively. But what they also have alongside them is companies. So they are looking to do research very proactively that solves the issues that the industry have today. So if you flip on one more. So we've also then allocated that into a collaborative R&D through Innovate UK. That's who I actually work for. And actually in that we've got 124 different organisations with 64 projects ongoing right now. And they've been going on since 2017. And what we're seeing is of that, we're starting to see real changes in how products are brought to market. We are seeing modelling, for example, using Faraday Institution projects coming through into the collaborative R&D and getting to market much faster. So we're starting to see that collaboration yielding positive impacts. We're seeing some really great success stories. And actually I'm going to pitch, because one of them and I are going to be talking on the 16th of July, just talking about their growth. So if you're interested in that side of things and you're out there in a company, come and listen and talk to us at that one. And then the last pillar, and the pillar that I really like because I'm actually a manufacturing engineer by background, is the manufacturing piece that UK BIC fits into. It's such a piece of the puzzle. So I spoke about vehicle it's for new vehicle development, and actually battery manufacture, cell manufacture in particular, is a continuous process. So mucking about with it to do trials, to do to change your settings, to try different chemistries, actually costs you a lot of money. It impacts your yield. And that's a very, very high cost at times. So what UK BIC does is it gives you a space where you can use cutting edge machinery that is in gigafactories, and you can run at the manufacturing rates, take your prototypes and run them at ton scale. You can do some short runs of pre-series batteries and cells, or you can actually just try those batteries, those cells that have come through, and actually run them flat out, and it will go wrong, right? So what UK BIC offer is loads of specialist knowledge to help you reduce the amount that will go wrong and help you learn from that, and also connect you back into both the institution and collaborative R&D communities to help solve that, because that is actually where the IP is incredibly valuable in that manufacturing process. But it also serves as a place that you don't have to take as a battery OEM, you don't have to take your gigafactory offline or mess around with things. You can go to that centre and actually do that. It's 200,000 square feet of prototyping and scale-up line, and it's flexible. It can do everything from your materials, cell materials, cells, electrolytes, through to pack and modules. So it's a really exciting place, and it opens later in this year. And actually, just to finish with the last slide, what's interesting is this is everybody's issue in batteries, right? We need cheaper batteries, we need better range, which is what energy density targets look at. We need better power, we need better safety. We want the first life of the battery to last 15 years. We want to operate in greater temperature ranges. We want to be able to predict how those batteries are performing through that life, and be able to increase the first life or decide what we're going to do with them for the second. And we need to be able to recycle them. And these were the targets that we set at the beginning of Faraday, and all we do is focus very much on them. But I just thought I'd put them up because what they do is they really focus you on those targets which are automotive. And the reality is it's not just automotive, and we're just about to launch a special interest group really helping define those similar challenges and the duty cycles that other vehicle applications have, from rail to aero. I think that's enough for me.
So Jacqui, Lars, thank you very much. So we have had some questions sent through in advance, which I have here, and I'll use those to sort of take us through an agenda. If you do have questions as we go along, then please do submit them. Peter will collate those and send them through to me by email, so I see them coming up. But I guess the first section, that we've had quite a few questions around the commercial situation and what the challenges there might be. So I think some of these probably, Lars, are aimed at you rather than myself or Jacqui. But the first question there really is, if you look at where we are in the UK, we've said there's lots of great things going for getting a battery industry going. But the elephant in the room is, of course, that we are not yet the other side of a trade deal. So we have achieved, we have now formally exited the European Union. But what we do not yet know is what our future trading relationships with the European Union will look like. So I guess, Lars, the question for you is, how much is that a factor for you in the investments that you make? And what would be your strategies to work with whatever outcome that might be?
If you look at the demand, single in the UK, we will be at least 50 gigawatt here in the next years, in the next 2025 at least. and 2023. And we intending to build 30 gigawatts. I mean, the demand is higher than the supply. So I mean, we don't really need to consider what kind of trade agreements we have in the short term, both with the US or with Europe or anything. We are fully busy with supplying the UK market with batteries and the British car industry and energy storage and the various applications actually that will be added on to our business. So I mean, we feel actually absolutely very comfortable and have full confidence in the UK market as it is right now. So I mean, I don't see any worries or any thoughts about Brexit or for us it says only being playing it our way really, as we have been more or less the single player currently on the market. So we are very happy and pleased with the situation as it is. So we have no worries about Brexit at all.
And I guess some of the car companies have been quite vocal in what the impact of a poor trade deal might be on their ability to continue their operations within the UK. Now, presumably that could have an influence on that 50 gigawatt hours per year number. Do you have a view on that?
That's of course true. But I'm very optimistic also that the trade agreement with Europe will be solved. For sure, we will have a trade agreement with the US, which secure the supply of cars to the American market, definitely. I mean, it's a very strong brands actually that we have in the UK right now. I mean, the Jaguar Land Rover brands are highly sought after, and you can always have objections about there will be collapsing in terms of trade agreements, but I'm sure within the time frame that we are currently operating in, as we are planning to be producing batteries in 2023, I'm very optimistic and almost quite sure that a solution on the trade agreement will be in hand at that time.
But Jacqui, I'm not going to ask you what the government's answer to that is, because that would be rather unfair. But perhaps if I can just ask you to how that background has influenced the UK government's willingness and ability to invest in these areas.
So I don't know whether it's just Brexit actually, and don't get me into trouble, Dave. I'll get sacked from government if I say anything too controversial. But that doesn't normally stop me. So I don't think it's just Brexit. I think COVID as well. I think what we're seeing, and I hope people in the next few weeks will see, is real clarity. And in that crisis, you always get a bit of clarity, don't you? About how important this is. I was seeing, senior executives in VW last week talking about how COVID-19 actually just brings forward this need for EVs and batteries much quicker. And the challenge is the shock to the car companies in particular, because actually, they don't have the cash being generated from their current models to do all that transition. So that there's a real challenge around how you do that. But actually the clarity over doing it, I don't think you're seeing. I think you're definitely getting messages from the UK government that is supported.
We've got a related question, which is many of the sort of big established battery companies have put down manufacturing footprint in mainland Europe. And what would it take to bring some of the others to the UK? Now, we don't have the others in the room, but we do have Lars. So perhaps if I can ask you, what were the things that were attractive for you in coming to the UK, but also what are the challenges that still remain in your view?
In general, giga plants or gigafactories, whatever you call them, is a quite new invention in that way. So it's not many out there, and what we are currently intending to build will be one of the largest operations in Europe actually, and to actually say what was going to happen post-COVID, post-Brexit, and how the new world will look like, it's more a guess really, but we can be quite sure that this new sustainable world actually will definitely promote these kind of initiatives. And I'm quite sure that what we're doing right now have a great impact on the whole system, actually, in the UK and also out of Europe. So I'm very sure that within a very short period of time, maybe just 10 months or a year, you will see a total different inflow of new businesses coming into the UK in the new green environmental society. That's how it's it.
So working in a university environment, obviously one of the key things that I'm looking at is training up the people that we're going to need to feed this industry in the future. And whilst a lot of these processes are automated, the scale of these factories is absolutely impossible to convey unless you've actually seen one for real. What's your view on the ability to sort of staff up and find the people that you need who are trained and have the knowledge to be able to operate a plant like this?
We are very optimistic about that. I mean, if you're looking at the educational level in the UK, it's very high. You have a long history of highly advanced in industrial production, which actually had skilled. You have a highly skilled workforce who is quite easy to implement in these new businesses. You also have the support from the government in terms of APC and UK BIC and Faraday institution. That it's been amazingly well furnished. As I said, actually, I don't think anyone realized how well prepared the UK are actually in these type of investments and to making it happen in the UK. I mean, there have been. I'm surprised actually that not many other big players have identified this opportunity in the UK. It's maybe the UK could have been more marketing this in a different way, perhaps. But it's still the fact it's amazingly well furnished, and it's like coming to a very ground smorgasbord in a way. So that's the way we see it. We are deeply impressed about it.
And certainly on our side, you know, in the work that we've done to try and build that infrastructure, we've had a really clear focus on all of the parts of the supply chain. The skills piece in particular, we've done a lot of work around the universities, and part of the function of UK BIC, Jacqui talked about it earlier on in terms of its ability to help develop technology, manufacturing technology, and prove it out. But actually the hidden delivery of that is that we will be producing hundreds of people who have got experience of building a battery factory and running a battery factory. And it is absolutely our expectation that those people should be moving into companies like Lars's in order to make sure that the companies that come to choose to locate here are as effective as they can be from day one. Jacqui, do you want to talk a little bit about the sort of skills that are happening through the Faraday Battery Challenge and the Faraday Institute?
Yeah, so for me, one of the big pieces that the institution does is it really does and has been ramping that knowledge up in the UK. We're seeing, I think now we've got to around 400 researchers across those 9 projects. And that's a really impressive number, and it's a number that is set to continue. And for me, what's impressive is constantly seeing how they work together, how actually by doing those competitions, those projects, they start to filter in different companies, different aspects, working with UK BIC. And I think the other piece on the skills, Dave, is not just the training of technicians and engineers at UK BIC alongside that PhD and researcher cohort, but also some of the practical knowledge that the UK then gets furnished with. So, you know, from planning and permitting, environmental permitting through insurance. And we're seeing codes of practice coming forward in the UK that I know I probably need to catch Lars up on, but on how to do things from a health, safety and environmental point of view. But going back to the universities, it's pretty impressive. You know, we are now, you are looking at what is beginning to really feel like a superpower in that research space, that actually we have MOUs with J. Caesar in the USA, for example, and we are talking internationally at that on that research level. And I guess, Dave, you see that too as being part of the expert panel.
Very, very much so. And I'd say that the Faraday Institution has kick-started the UK academic community in a way that none of our normal funding methods has done. And it's really got a very significant body of research, very clearly focused on some industrial questions. And industry hasn't told academia how to find the answer, but they've told them what the question is that they want answered. And that's been really catalyzing in bringing together hundreds of researchers in, with program sizes of tens of millions of pounds to really move the dial, both on some of the nearer term aspects of the battery. So, for instance, the manufacturing technologies that we might be using, or how we might be recycling them, and also some of the longer term ones. Some fantastic research now going on solid state batteries, on lithium anodes and those kinds of things. But that leads us actually quite nicely into another set of questions that have been sent through, which is around the material supply chain and what the future direction for battery technology is likely to be. And the first question within that was, given that the raw materials that we need for this are predominantly not mined and refined in the UK, does that really leave us at some huge disadvantage? Has another country already monopolised that supply, and we're out of it? So perhaps, Jacqui, if I ask you to that one first.
I guess I'm a metallurgist and I used to work in extraction metallurgy, so I can understand a little bit about refining. But I think so we're all really clear that for rare earths in particular, although that's not batteries per se, that's perhaps the battery management systems and the motors and drives needed for EVs. But we are seeing real dominance from China in refining, and it makes perfect sense to me. I don't know about Lars, but where they have been very canny and had this long-term strategy, if you're refining and it's close to your gigafactories, then you've got both technical but also cost benefits that you can bring through. So yes, I think China has been incredibly clever long term. Where it's had the natural resources, it's built on those and built that refining knowledge. Where it hasn't, you've seen it very clearly take up market position, where, for example, for cobalt, it's very clearly controlling a lot of the world cobalt refining. However, weirdly, the UK has a history in this. It's not just because I come from the steel industry and I know that history. We also have things like a phenomenal refinery. I think it's been there since 1908 for nickel, and it's a secondary refinery, and it produces aircraft quality, aero engine quality nickel, and it has a byproduct of cobalt. So when you start to break down that supply chain in the UK, there's some real opportunities. So with that keystone, as I spoke about earlier, of Gigafactory, with people like Britishvolt now circling and being really interested in putting down and breaking ground in the UK, what you start to see is the ability to ramp all that up. And it can be things like not just refining, but you've got to think about the whole piece. And what I think the UK also offers is greener energy. And some of those production processes are greener than in other places, and you have to take a life cycle assessment. And I really endorse Lars's sort of USP about that environmental impact. It's hugely important in this space. And I know, we all want to be a bit cynical because everybody wants to think that the world's going to get overrun with EVs and batteries, and it's going to be worse for the world. But actually, we know how to control this. We know how to regulate it. We know how to refine efficiently. We know how to actually make more efficient EVs. And those things will grow as that arch that you saw earlier and that keystone come into place. And I think the UK has a brilliant set of skills from how you put battery propulsion into a vehicle that gives them something for the long term. For me, it's been the most exciting 3 years being in this space, and I can't see it getting less exciting.
And Lars, clearly from your perspective, you don't see that material supply chain as a barrier, or you wouldn't be looking to build a factory in the UK. So what's your view on how that situation is likely to evolve over time?
Yeah, I mean, it definitely is an issue, and we have addressed that also, and are initiating roundtable discussions actually to encourage supply chain operations in connection to our Giga plant, and that's ongoing work and collaboration that we are recently launched, initiated, and that we hope actually will cure some of the issues, and also make it possible for suppliers and other manufacturer to join us our mega site, and even have companies from outside the UK to establish in UK to support us in this process. So definitely it's something that we take very serious, and addressing those problems. Also would like to fill in that we also intending, what we are doing now for the site that we have identified in Wales, is that we are adding on with a solar park, a 200 megawatt solar park, and that's also been a bit of a challenge actually to find land where you can have, first of all, you can have the mega site, which is quite large, and also on top of that add on with a solar park. So that's a bit demanding actually to find these kind of sites actually in the UK. Most of the lands are owned by developers, and the sites are not big enough and so on. So that's an issue, and but I think we have managed to identify a few of those opportunities actually.
Excellent. And another question that came in that was probably sits with me first, I think, is various companies, Britishvolt and CATL, are now offering cobalt-free cathodes, and the question is around what's going to be the next material, what's going to be the next battery technology. So I guess given what I do for a living, I'll start with that one. I think what we're seeing at the moment is a very much evolving market for electric vehicles, as well as an evolving set of technologies which can serve them. So where we are today, with a relatively sparse electric vehicle charging infrastructure, the need for vehicles to have very high range is still there. And so if you look at the way that particularly premium vehicle manufacturers have run, it's all been about packaging more range and faster charge into their vehicles. And that's tended to take us in a direction of high nickel, cobalt, manganese, NCA type materials. There's still plenty of space for us to develop that family of materials. I do think that you'll see the cobalt down. I think you'll see the manufacturing costs coming down. I think there's quite a lot that can be done around process and quality control to improve yields and bring costs down that way as well. So I think there is a trend which will see those materials get better. But the other counter trend, which is exciting, is that as you see the charging infrastructure improve, the need to carry a battery around that does 300 miles or more of real world range starts to go away. And if you actually study the travel patterns of most people in the UK, a battery with a real world range of 150 miles, which could then be fast charged in a matter of 5 or 10 minutes at a motorway service station, starts to become a much more economic proposition. And at that stage, you don't need the materials with the ultimate energy density or the ultimate power density anymore. And suddenly you can open up the market into things like the lithium iron phosphate chemistries, which are a lot of the cobalt-free chemistries that you see coming from China. You can also open up the market into things like sodium ion, which is an area that the UK has a particular strength. And what's really interesting about those is that although the materials are fundamentally different and they're sourced differently and they have much lower costs and they're typically more environmentally friendly, the manufacturing processes that you use to build that generation of batteries will pretty much slot into Lars's factory. It'll have a slightly different makeup of grey powder that goes in at one end, but the cells that come out the other end will be made in the same way and will perform in the same way. So that's not a difficult thing for us to cope with as we go through that market transition. There is a next generation of batteries that sits beyond that looks at things like solid state, that looks at solid lithium anodes, and that looks at some multivalent chemistries. But really, they are still in the laboratory today. And that means that knowing that it takes 6, 8, 10 years to take something from the laboratory, prove it out at scale, work out how to manufacture it economically, build the plant, prove the plant, and then sell it into a product which itself has to be validated. Realistically, that's the timeline between exiting the lab and hitting the market. So I do see some really good opportunities to bring some lower cost and more environmentally friendly materials through into the supply chain. But I'd say if you were to look at the moment, I think the lithium ion family of chemistries that we've got around us now is going to be the one that will sustain us for the next 5 to 8 years. And then beyond that, there are some good opportunities, but they don't need massive disruption in the manufacturing chain for cells, modules, packs, and battery management systems.
I think it comes back, Dave, to the point around we're really on this journey to net zero, right? And how we get there is going to be a rainbow of solutions. You know, we're not going to see internal combustion engines finish as soon as we really truly come out of lockdown, for example. Nor are we going to see the end of lithium ion batteries for a long, long while, because actually there's so many more applications coming forward that need much, much lower CO2 emissions associated with them. And I guess talking about those materials, the other piece, of course, is that ideally we don't want to have to carry on digging these things out of the ground. Whilst we will have hundreds of thousands of tons of material in circulation in vehicles. So then the question comes, how do we deal with that? First of all, from an environmentally responsible perspective, so we don't end up with huge piles of dumped batteries around the UK. And secondly, from a commercial perspective, how do we get those materials out of spent batteries and back into our supply chain? Jacqui, I know this is an area that you've been looking at in some detail recently. Yeah, there's a confusion here, I think, from a regulatory point of view. So right now, all car companies are under the End of Vehicle Life Directive. Now, whilst that does not include batteries, it does put the producer responsibility on them. I'd be hugely surprised if you would find an EV battery dumped. That said, consumer batteries, they're in mobile phones or everybody's cordless Hoover that we all now need, and we must have our cordless tools around the house. Those ones, they're entering a different waste stream. They're entering the municipal waste stream and are causing problems. EV batteries, are coming back to car companies. And actually why, they are also classed under the Batteries Directive. They're not allowed to go to landfill. We know this. The issue really is that Batteries Directive is getting revamped as well. And that's to really increase the recycling rates as per the End of Vehicle Life did. For automotive, you have to recycle, I think it's 95% by mass. So there's going to be some more and more and more regulation in this space. But actually, for me, what's exciting is things like the Faraday Battery Challenge also sponsors that innovation, and you're seeing a big focus on this. And the reason there's such focus is not just from environmental concern, but also because cars, if you're selling electric vehicles, you are selling to consumers who want to have the confidence to know both the environmental credentials and also the slavery or whatever credentials are what they think they're buying. And I know the car companies are incredibly focused on that too.
And Lars, you mentioned in your talk at the beginning that you see that closing of the loop as being an integral part of your business model. And to sort of talk us through that, how that fits and what you'll need to do to.
Can you repeat that, David? What do you mean with the close?
Sorry, yes. So you talked in your introduction at the beginning about the need for recycling and recycled materials to become a part of the value chain. I just think it'd be interesting to see it from a manufacturer's perspective. Where do you see the value in that, and what do you see your role?
That's something that we are also addressing very seriously. We have launched the Britishvolt Infinity, which actually is a project where we aim to have 80% recycling of all the batteries that we are producing. All the rest products of our batteries will be recycled up to 80% of the materials within the batteries. And that's a process that we are currently just launched, and we also have invited a few other companies outside Britishvolt, which is recycling companies that we are hoping to team up with in this process here in a very short period of time. We will also announce that also in the next weeks here. So it's a very important part of the whole process. As I mean, we are struggling to have a zero emission process and a facility that will support the environment and be totally sustainable. And we have many toxic parts in the batteries that we all are aware of. And these need to be addressed, and we need to work as hard as possible to minimize all this process already from the mining process up to the assembly and for the use and for the recycling. So it's a very, very important issue. And I mean, the whole process actually fails if we cannot be successful in the recycling process.
Thank you. So I'm just slightly conscious of time. So for anybody who sent a question through that we haven't been able to address directly, I do apologise. I hope that we've covered the areas generally enough for you. Up and come back to our original question, you know, what does it take to bring a gigafactory to the UK? I think with Lars on the line, the answer is we've sort of done it, which for me is fantastic. You know, the last sort of 8 years of my life have been spent trying to build the infrastructure that Lars referred to as being the attraction to come here. And clearly we wish every success with that and with any other battery companies that may come to follow. So I'd just like to say, you know, a huge thank you to Jacqui and to Lars, and I shall hand back to Peter to close the session. Thank you.
Thank you, David. Thank you, Lars. Thank you, Jacqui. What a superb session. Lots of interest, and especially thanks for your resolve in ensuring that we overcome technical challenges, especially with the web and whatever. Lars, you chose the right place to come with a factory, because we do have tremendous amount of resolve in the UK to overcome things. And also, thanks for coming to the UK. So as we've overrun slightly, thank you all. It was a superb session, and I hope to see you all again. Take care. Thank you.
Cheers.
Bye. Bye.
Thank you.
Thank you.
Bye.
Bye.
Bye.